Hi everyone. Welcome to my second lecture on fun mathematics. Today's lecture is about two things. One is golden ratio, and the second one is Fibonacci sequence. These two are also closely related. We're going to see how this is going to play. Let's talk about Fibonacci sequence first. Fibonacci is something that you're in class 9th right now. You keep hearing this if you're in class 9th or class 10th. You keep hearing this like throughout your life, throughout your education, what you call time. Suppose you study graduation, undergraduation, post-graduation, everything. So you keep hearing about the Fibonacci sequence all the while. So it's important when you're taking competitive programming. This is probably the first program or the first two programs that you actually write. Let's see what a Fibonacci sequence is. You have to remember the first two, like the two numbers in the series, that's 0 and 1. And the third number is nothing but the sum of the previous two numbers. Suppose you take the Fibonacci sequence here, 0, 1, and the next one is 1, 0 plus 1. So what is 0 plus 1? 0 plus 1 is 1. So the next number is nothing but 1 plus 1 is 2. And next number is nothing but sum of 1 and 2. The next number 5 is nothing but sum of 3 and 2. So in general, any number n is given as sum of n minus 1 plus n minus 2. So this series can continue infinitely as the numbers are infinite, like the sums are also infinite. So why is it so important? I think it is present everywhere, right? I think we might not have realized that it is Fibonacci, but Fibonacci is used in stock trading. Fibonacci is used in everywhere else. But let's see where it is used. I meant like some places where it is not supposed to be used or not known it's being used. Suppose you see in nature, how many of you have seen sunflower, right? You might have used sunflower oil. The only way I think we know sunflower is because people are living in urban areas. They'll not be seeing sunflowers usually, but you can see them on oil packets, right? Maybe I think in Google and find seeds grow in spirals and often 34 clockwise and 55 counterclockwise, right? So what I'm trying to say is like the seeds, right? If you see this, they grow in clockwise and counterclockwise direction. They are arranged in this direction, right? So what is clockwise? Like clockwise is what is in this direction, right? So let's say counterclockwise is this direction, right? Some of the seeds are growing in the opposite direction. Usually, when you take a sunflower and actually count it, um, that seeds usually will be either 20, what you call 34 or 55. These 34 and 55 are also Fibonacci sequence numbers. After 21, I think was the next number, 21 plus 13 is 34. After that, what is the next number? Is 55. So you get 34 here and you get 55 next. So not only in sunflowers, you see daisies. Daisy is a flower. Daisy's petals are often 21 or 34. We studied the Fibonacci sequence, but sunflower did not, right? I think who told sunflower to always, like, I think, have seeds in clockwise and counterclockwise in Fibonacci sequence? It's a little strange, isn't it? Even the same pattern is observed in pine cones and pineapples. Right, the spiral pattern follow the Fibonacci numbers. So in nature, nature doesn't understand mathematics. And so what does it say? Like, given there are some constraints, right? What is the constraint for sunflower? Sunflower needs to grow, like I think, a little bit fast. Like for it to grow, like it always points in the direction of the sun, right? So that there is a maximum sunlight. And what is the constraint? There is only limited space, and thousands of seeds are sprouting inside the sunflower. So what happens is they tend to follow this Fibonacci numbers, right? The important thing to know is like similarly, any constrained environment, if you leave it like that, right? So it tends to take a Fibonacci numbers because that is the optimum way in which it can align. So a sunlight angle point of view, I think we will deal with it later. It's also called a golden, what you call a golden angle. We'll revisit back to the sunflower. But as of now, like I think given you leave it with some kind of a constraints, then always nature also tries to tend to take it in Fibonacci sequence. And that's the important thing that you need to learn here. Next, we're going to talk about golden ratio. Fibonacci and golden ratio are like, I think, related. How they're related, I think we'll get back to that. What is a golden ratio? A golden ratio is denoted by uh, a Greek letter called phi. It is pronounced phi, not pi. It is pronounced phi. F double E, like I think in Europeans, like I think phi. So something like phi, or something like that. F double E, phi, or phi, it is pronounced as like I think E in Europe. So something like this, the pronounce phi, phi. So people usually confuse this with pi. Pi is also a Greek alphabet, I think. So pi, radius of a circle, I think we actually say pi. And I'm not drawing it legibly. I hope you understand, like radius of what you call area of a circle, pi r square, 2 pi r. And that pi is pronounced differently. It's pronounced phi or phi. The golden ratio comes from dividing successive Fibonacci numbers. If you see Fibonacci sequence, I said like I think 21, next one is 34 and 55. The higher you try to go, right, 21 by 31, if you divide, it will be 1.615. It's called golden ratio because it is also just like Fibonacci sequence, it's also available anywhere, right? The higher you go, like in Fibonacci series, the more closer it gets to golden ratio. So what is golden ratio? 1.618. And it has immense significance. If you have read some book called Da Vinci Code, I think it, it is made as if the entire thing in universe is based on 1.618. Mostly it is true. Some amount of exaggeration happened in that particular novel, Da Vinci Code. So if you see, the higher it goes, like the more closer it comes to the golden ratio, right? So that's important, and that's something that I want you to understand. So just like Fibonacci sequence, in nature also, you can find golden ratio very often. Shells, right? You might have seen seashells when you're on a vacation, right? So seashells are like that. Usually snails live in that. This is how seashells are, right? Each turn about 1.6 times larger. So even in terms of what you call galaxy, same as seashells, our galaxies are also spiral in nature. Our DNA is spiral in nature. Each quarter turn, right? What is a quarter turn? Let's say from here to that. So this is a quarter turn, right? Each quarter turn increases by 1.61 times. From the center, obviously you have to take it from center. And when you take it from center, each quarter turn, the radius actually increases by 1.618 times. Why? What are the constraints here? So the constraints are gravitational pull between galaxies and between internal, what you call planets and other things inside a galaxy. Right. They're even galaxies or what you call a shell that you simply see. You can also see the same pattern in the shell. Suppose look at the shell in which snails live. So it is exactly the same pattern. So even the simple seashell versus bigger galaxy, everything actually the radius increases in the golden ratio. So not just that. So if you see hurricanes, galaxies, right, everything expands with golden ratio, right? An interesting exercise probably will be like go back and in a human body also, from navel to what you call the feet, head to navel, the ratio is 1.61. Right. If you take your hand from the tip of your fingers to elbow, like an elbow to shoulder, the ratio between what you call shoulder to elbow and elbow to tip of fingers is also 1.6. If someone is having what you call a very larger ratio, he probably is Bahubali, like, and most of us, it will be closer to 5. And one of the exercise probably would be you can measure from head to navel and navel to toe and see like I think how close you are to 5. It also depends on the growth spot and other things, but eventually, like I think most of us, it will be 1.61. The people who are like bigger, right? If you measure your hand, like I think someone, it's called Ajahn Bah in some variant of literature. I think people call people with longer hands are Ajahn Bah, or probably the more recent one is a Bahubali. So all of us are not Bahubalis. So most of us, we should be closer to golden ratio. It would be good exercise to actually uh, measure and see like I think how it is and don't have to tell to anyone else. All right. What is the connection between Fibonacci and golden ratio? Fibonacci sequence essentially lead to golden ratio because as you have seen, the Fibonacci sequence, as it grows, the ratio of the number before to this one is always the number to the what you call when you divide 21 by 13, I think it will be 1.61. It will be the higher the numbers are, the closer it goes to 1.618. There is also one more thing, right? Um, one more thing, sunflower seeds, I said we'll go back like I think one with them. Sunflower seeds also will be at an angle of 137 degrees. What is 137 degrees? If you take a circle and divide that into two sectors, this is an exercise for you. Now figure out what is a golden angle. I think it is around 137.5 is called a golden angle. So why is it called golden angle? If you divide a circle into two sectors, right? If you divide a circle into two different sectors, unfortunately, I'm not able to do this nicely. Yeah. So if you divide, then in such a way that one sector, the angle that is created here to the angle that is created is 1.618. Then I think one smaller angle will be 135, 137.5 something, and the bigger angle will be the remaining. So 137.5 is also called a golden angle. Why is it called golden angle? Sunflower seeds also align 137.5 degrees so that they get an optimum sunlight. So in this lecture, what you learned about Fibonacci sequence, you learned about golden ratio and a golden angle. Thank you. I think if you really like it, please do subscribe. And I'd be glad to bring more content here. You can also put it in comments, like what kind of content that you want to watch. I'll try to keep updating the content in that direction. Thanks for following Fun Month.